Okay, so I think we're ready to get started. Good morning. Welcome to the latest edition of our virtual tech webinar, meetup webinar series. It's my great pleasure today to be introducing Lewis Cianci, who's going to be doing his talk on understanding Flutter streams. Before we dive in, just a quick word from our sponsors. So today's webinar is brought to you by LogRocket. I'm sure the majority of you tuning in today will be familiar with LogRocket from our blog. You may not be aware, though, that we actually have a great product for when you're building and fixing applications. LogRocket is a front-end application monitoring solution. It combines error tracking, performance monitoring, infrastructure monitoring, and web analytics all rolled into one. So your engineering teams and your product teams can all use a single source of truth for every aspect of app development. So you can have more efficient remediation of your problems and iteration of your feature sets. In addition to this, you can integrate with all of your existing backend monitoring tools. For more information, head over to logrocket.com, where you can get a personalized demo or sign up with a free account and just get a sense of what it can do for you. With all that out of the way, I would like to invite Lewis to give his talk. Just so you know, a recording of this will be sent to you. In addition, an upload will be uploaded onto our YouTube channel, so you can watch all of our previous editions of Meetups, as well as this one we're doing today. In addition, we do have some upcoming meetups for the end of this month and for early next month as well, in addition to 3 more for November, which will be going up this week. You can follow the URL in this slide right here, or you can just Google Virtual Tech Meetups LogRocket and you'll find it no problem. Now, without further ado, I'll hand over to Lewis.
Thanks for that, Jack. I'll just share my screen. All right. Well, hey everyone, and welcome to today's webinar on how you can understand streams within Flutter. By the end of this session, you'll have a much better idea about how streams work within Flutter and how you can make great use of them within your app. So to understand first what streams are and where they fit into the overall landscape of Flutter, we should take stock of what types of functions are available within Flutter, and also think about how hard it is to take advantage of these different types of functions. Obviously, today's talk is about Flutter, but we'll be talking about the Dart language, which is obviously pretty important to the Flutter framework. So for starters, we have normal functions within Flutter. These are functions that aren't asynchronous. An example of a function like this is the datetime_now function. It's not asynchronous because it's extremely quick to resolve. According to my very quick tests on Dartpad, it only really takes about 100 microseconds to produce an output. And in reality, it'll be much faster than that in a production app. We've got the 100 microseconds to spare, so datetime_now doesn't have to be asynchronous. But the next type of functions we have are, still in normal functions. These functions that like datetime_now, they're really cheap and they're easy to use. We don't have to do anything different to use them. We just call them whenever we want. And as a result of that, they're just very easy. They're very straightforward to use. Of course, after this, we have our future functions within Dart. And these are functions that are asynchronous, that emit once with a return value. These are the functions that can take a little bit of time to complete. We can't afford to run the particular operation synchronously because it would make our app pause or introduce some level of jank. And most times we'll deal with these by specifying a future as the type, and then the type of the future itself within the angle brackets. These are about the same as tasks within C# or promises within JavaScript. They all resolve to a result after some time. In my example here, we can see that I run a HTTP GET request to a website, and this has taken quite a bit longer than our datetime_now function. It's still under a millisecond, but this could be a lot longer on a slower internet connection. So using a future in this context makes a lot of sense. Futures do require a little bit more thought than normal synchronous operations. Usually, if our function returns a future, it means that the function calling it must also be able to handle asynchronous operations, either by being async itself or calling the then operator on the function in question. But in reality, they're not that much harder to use than normal functions. And as a result, they're pretty easy to use as well. Which brings us into tonight's topic, or today's topic, and that is streams. So a stream is just something that can emit multiple values over a course of time. You can create a function that emits to a stream, but as we start to increase the complexity around our asynchronous operations within our app, it's kind of easy to maybe start to handle them incorrectly. And they can be a little bit intimidating to use. After all, if you don't clean up after yourself, in some situations, you might introduce memory leaks. It's also possible that a stream never actually completes for some reason, and it could just, hang your application in a never-ending loop. As a result of this, and for some other reasons, it can be tempting to just leave streams alone and just stick with features. Streams are definitely a little bit harder than features, after all. But we don't want to do that, because as smart, motivated developers who want to make full use of the technology that the framework provides, we want to work out how we can use them properly and not just skip them and leave them by the wayside. So we really need streams with our apps, and they serve an important purpose. They help us to create fast and responsive apps. In reality, Dart makes it quite easy for us to handle streams, and does so in an intuitive and easy to use manner. Handling streams effectively within our app itself contributes directly to the performance of our app, while also making better use of resources. And as we know, releasing a performant app that makes great use of resources while being resilient to failures will result in many, many happy users. So now what we'll do is let's have a look at an example of a really simple stream. And we can see down at the bottom we have time, because a stream emits over time. So our stream begins when something starts listening to the stream in question. After some time, an event is emitted, then another event, and another event, and then eventually our stream completes. And really, in a perfect world, that's how we could expect our streams to behave most of the time. But unfortunately, we don't live in a perfect world, and things occasionally do go wrong from time to time for a variety of reasons. For example, phones can lose network connections, run out of room, or experience some other problem. And when that happens, our stream will encounter an error. When that error is triggered within the stream, our stream will exit in an errored state, or call the on-error handler if you happen to have one set up. So now what we're going to do is we're going to have a look at a practical example within Dart to see how these streams work. So really quick, I'm just going to hop out of this presentation and bring up the Android Studio that you can see that. Okay, so as we can see here, this is Android Studio, and what we have here is a incomplete Dart application. So this isn't a Flutter app just yet. It's much simpler than that. It's just the Dart side of things for now, as we start to understand how streams work and how they go together. So we can see here that we have an example of a stream, which is quite basic. It just counts from 0 to 5, waits a second on each loop, and then yields the result. So this yield keyword is unique to streams, because streams don't so much return a value like a normal function. You might have a function normally run to completion and then return a result, whereas streams will yield results over time, so they can yield more than once from an individual function. We can see here as well that when I've set this up, simple emitter function, we have this async keyword, but we also have a little star next to it. And what that star means is that what async star means in this context is that this is a yield generator function, because it will continue to generate these calls over time and continue to contribute to that stream as well. So really quick, just to make this application work, what we'll do is we'll make use of the stream to produce an output. And sometimes with streams, it can be tempting to come into them and find the stream that you're after and maybe type something like listen and then try and use the result. And that's an okay way of using a stream. There's certainly nothing outwardly wrong with it. But Dart actually gives us an easier way to interact with streams, which I didn't realize until after some time of using streams. And that is using the await for operator. What await for lets us do is we can wait for every event that comes out of the stream. So we can go wait for final result in simple emitter, open bracket, and then we'll just type in print and we'll go to result. We'll save that and we'll run that. So down the bottom, we can see that we get our result as expected, which is we use this simple emitter stream and then we just print the results as they come out of it. And that's easy to see. Waits a second, it yields a result, and the result is then printed to our output. So that's pretty much as simple as a stream as you'll ever come across. But what happens if you start to encounter errors within your streams? Well, I'll just make that a little bit bigger. Well, errors, as we spoke about before, are just a fact of life. So what we'll do is we'll just adjust this simple emitter function to accept a list of integers. And then we'll get rid of this function body and we'll iterate through these numbers. We'll do a similar thing, pitch delay, duration. What we'll do is we'll just make the number 2, it'll throw an exception saying, I don't like the number 2. But then we'll do the same things as before, which is this is result number. Okay, so then we'll do that simple emitter call up here. We'll just say 1, 2, 3, 4, 5. Change the right example, and then we'll hit the go button. Now we get our output as per usual, but as we would expect, we get that exception thrown. And if I just quickly turn off breakpoint handling and resume it, we'll see that our app essentially quits at this point in time. We've encountered an error within our stream. We haven't handled it. We haven't specified what to do in case of an error, so our app just simply quits. So obviously that's not a great experience for the customer and for the people that use our application. So we would like to bring in some level of resilience and some level of trying things out to see if they work or not. So what we'll do is we'll wrap this in a try block, and then we'll just catch all the exceptions. And we'll add another print here. Extension call. And then what we'll do is we'll try it again. But this time, we'll skip the number that has a problem with. So 1, 3, 4, 5, for argument's sake. Open bracket, print, retry, event. Save that. Right example still. And now let's see how that goes. And we can see our output down here still. So we have that result happen, the exception gets caught, and then we see the retry occurs. So even though we're using this await for terminology here, this language feature, in case of an error, our outermost try catch block is triggered in case there's a problem, and then we can pursue our retry logic as we would like to. In reality, you're probably doing more than printing numbers in your production code or apps that you deploy to people. But this starts to give you some idea of how we can handle errors within our stream and possibly implement some sort of resiliency or some sort of retry. So the next thing we'll consider is how we join these streams together. So there are times when you'll have possibly more than one stream. You might have a stream coming in of battery level and network connectivity, for instance, and for whatever reason, you may want to join these streams together or call other streams while you're already in a stream, and then yield those results up to the single caller, the call the original function. So we have here our same function from before, our same code from before, which has that inbuilt error handling in it now. And what we're going to do is we're just going to go ahead. We're going to add in another string. We're going to call it simple string emitter. So that's going to be a list of strings and strings to string. And that's also going to be a yield generator function. We'll say for final string in strings print. Right, feature line one, and then we'll yield the string. So now because our original function still calls this simple emitter function, we'll go ahead and we'll hop onto this line here. We're checking for the number, and we'll then do another await for, final string in simple string emitter. And we'll just call it 1 and 2. Finally, we'll come into here, and just so we can keep track of what's going on, we'll have this as main, and then the string that we're printing. And then we'll have this as simple emitter. String. And then we'll do the same thing down here as well. And then we'll just go ahead and we'll run that. And we can see there what's happening is we have our result 1, then 1, 2, then result 3, and 1, 2, and so on and so forth. And all this is happening despite the fact the only print call is occurring within our actual main loop. So what's occurring here is that we are within our simple emitter function, and then even though we're here tapping into another function, because we're calling the yield keyword, it's yielding essentially all the way up that trail to the topmost function. Another way of possibly doing this is if you wanted to comment that code out there and then just use the yield generator function itself on the simple string emitter. And again, with the same parameters, 1, 2. And if we move down, which definitely is line. And then if we debug on that, we can see that we should get more or less the same result. So what's happening here in this case is we're using this yield star command to essentially call the simple string emitter function, but then connect the string from it into the caller of simple emitter. So even though within our function, our calls may go several layers deep as we subscribe or unsubscribe from other streams within our functions, our caller will only receive one stream as long as that stream is of the same type as what we've been calling originally. So that's the simple Dart examples, which hopefully sort of introduces you to how these streams work and how some of the bits and pieces done. And just on that, just to step out a little bit further, we saw that yield operator there, that yield star operator, and it's pretty powerful. It's pretty powerful. It's cool that you can connect into lower streams from within existing functions that are streams themselves, because it will pipe the results of the new stream we're calling back into the caller. If the caller is on another stream, it will continue to pass it up the chain of yields. So as I said, you can be quite a few layers deep, and it will just pass up the stream and what's being emitted over that stream all the way up to the original caller. So that in itself is is pretty good. It makes for an easy and intuitive way of dealing with streams. But there's an issue with this, where if we have a infinite loop, or something gets stuck, or we don't handle something correctly, and we're quite deep within these yield generator functions, if we have an infinite loop, as we have here, even though we're 3 functions deep, it will never return. So it will just get stuck there, and it's possible that your app will just continue to load forever because that yield generator has never returned. It'll wait forever for that to come back pretty much. So now, with that covered off, let's have a look at a practical example of an app that I created that uses streams. So I'll just go ahead and start this app up quickly. It'll just take a second to build and deploy to the device. So what we have here is a really simple app, and it's just an app. It's just called the something to do app. What it does is it leverages an API, which is called the board API, as in BORED API, for certain tasks that you can look at to do if you're possibly bored. How it works is that it uses streams to request new activities out of the board API, which are then submitted to a stream internally within the app. If I go ahead and if I hit the search button now, what will happen is we'll get an activity suggestion, which is to go to a local restaurant. We also get the amount of people that could do this activity, how much it would cost, although I'm not sure if you could find a restaurant for 20 cents, and how hard it thinks that particular activity would be. So we see that there's streams coming along, and it's just out there is reacting to these events that are happening every stream. Every 10 seconds, it's going and it's getting a new event, a new activity from this API and bringing it into our app. We also have some filtering where we can only filter by certain types of events, certain types of activities that match a text filter, which I'll get into in just a second. But to get started, a lot of this revolves around a service that I wrote. And we'll just have a quick look at how this works and how it goes together, because this is really 99% of how the data is requested and how it's returned from the board API. So we can see here that we have a StreamController first up in that activity service. So StreamControllers are kind of like Grand Central Station for your streams themselves, because they let you have a stream which you can send things into, but they also provide a sync as well. So you can send events or objects directly into StreamControllers, and they'll get sent as to things that are also subscribed to the streams within. This individual StreamController, as you can see, is prefixed with an underscore, so it's private to this individual service. We only expose the actual stream of the StreamController because that's all the consumers need to know about is the individual stream itself. We also have here an ignored stream, which is where the ignored events go if they don't match the filter, which we'll go into in a little while. Then we have our timer, which controls sending the same request every 10 seconds or so. Within our constructor, we set up the StreamController for our activities, and then we set the activity stream, which is the public, which is a public property, which other things can access. And you can see here, it's just setting it to the stream within that StreamController. Then we have a couple of functions. We have obviously, we've got here start stream, which will take care of getting an activity from the API, which will come back, and then it will, I shall just step into that get activity. So get activity is asynchronous because we call the await command on it. If I click into that, we can see that we get a response. We wait for a response from our board API, and then we deserialize it into an object that we can work with. And then we do some checks. If we have a filter, then if we have a filter and if it matches that filter, so if it's something that we are looking for, it sends that activity into the stream. But if it doesn't match the filter, then we send it into the ignored stream. Of course, if there is no filter in the first place, if it's just null, then we just add all the activities because they're not filtered by anything. So going back to our, so we call that function to get the activity. We cancel if there's, we cancel any existing timers if they exist, so we don't run multiple times at the same time. And then we start a new timer. Every 10 seconds, we would like to run the get activity function, which of course will submit things into our streams as we need to. And finally, we have our stop stream. We have our stop stream command here, which will just stop the stream and stop it from emitting new events by canceling the request, by canceling a timer, and stopping it from emitting any new events. So that's really how the data aspect of this works, or how the network aspect of this works. It requests things from the network, from the API, and then submits them into that stream that we have set up. So coming back into our stream viewer, just briefly, this is the actual app itself. It's pretty basic. And almost immediately, we call it Stream Viewer. So the Stream Viewer itself is a little bit more complicated, as we can see, because of handling our UI. We have a bit more things to do here. But the first thing we do is we create a new activity service, which is a thing that handles our streams and connects to the API and things like that. And we also set up a stream subscription. So sometimes you will want to listen directly to a stream, or you might be using a certain widget within Flutter that listens directly to a stream. But sometimes you might want to trigger events from what's happening in the stream. You might want to show a loading indicator or something like that. And in cases like that, you would want to subscribe to that stream and then make decisions based on the events that are coming in. And we'll see how it works in just a second. And then we just have our text editing controller for our little text box there, which you can see. So when we start to get set up with this widget, the first thing we do is we set up our stream subscription here by subscribing to the ignored stream. And the reason why we do that is because every time an event comes in that doesn't match the filter, we would like to show a stack bar down the bottom with the name of the event that we're ignoring. Obviously, it's a bit of a contrived example, but it goes to show how we can use events from streams to show snack bars if we want to. So we can see that code that goes here, that it'll instantiate or create a new snack bar, hide the old one, and then show the new snack bar, which we'll see happen in just a second. And that brings us to our build method. And we have a list view here in the container and everything that sort of goes towards rendering our goes into rendering our UI that we can see here. But where we get interested in what we're doing for this video tonight is in the StreamBuilder widget. So StreamBuilder is sort of like a convenience widget that Flutter provides to us to easily let us interact with and draw our UI based on what's coming in over a stream. It's something you probably could implement yourself, but because the Flutter team is good to us, they decided to do it for us. And that's a good thing, because obviously, if they've made Flutter, they have a really intimate knowledge of how the widget tree works and how it all goes together. So with that, we get some really good functionality. We are able to specify a stream that we would like to listen to. We also specify the type that the StreamBuilder will handle. And then what happens is that every time a new event is received over the stream, Flutter will redraw this widget for us, which means that we're not going to have stale data there, because every time a new event comes in, the widget's going to get reloaded with this new fresh data that's come over from the stream. So we can see here that we have our builder here with a context, which you would expect. And then also we have a snapshot. And what this snapshot is it's an async snapshot. So streams operating over time, where they start, emit 10 times, then 10 seconds later, then they finish. An async snapshot is the state of that stream when that event came through to it, at the moment when that event fired. So every time we have that event fire, that new event come through, or new object come through that stream, we are going to see this redraw. And every time that happens, we need to check some things. So if the snapshot at this point in time, if it has data, then we would like to draw the widget that shows the task, that shows what the task is, how many people are required, and so on and so forth. But we can see here that we're accounting for if it has data, what to do, and then as well as that, if it doesn't have data, what to do. And if we just restart the app, we'll see that we get that no tasks yet display. So now what we'll do is we'll just try and trigger that filter. So put in gym because at least one of these tasks has the word gym in it. So everything that doesn't have gym will be ignored and we'll get a snap bar for it. So we'll go ahead and hit search. And we can see here that every time an event comes back, or every time a task or activity comes back from this board API, it doesn't have the word gym in it, it gets ignored. And instead of coming in and updating that StreamBuilder, it instead leverages the code that we looked at a little bit earlier on, which is listening to these events coming in, as we can see here, and doing something in response. So that's pretty much, that's how we use a stream and a StreamBuilder in order to draw out a UI within Flutter. The StreamBuilder also has other available things to us. For example, it'll help us see if a stream is in an error state, or if it'll show us if something bad has happened to our stream. So if we just hit the dot off that, we can see that we have these helper things like has error and the error itself, and all the other things we can use to create a better experience for our users, and also explain to our user what's going on and the steps they can take to possibly remediate a certain issue. So after all this, another thing that becomes really important is because our streams listen, because our StreamBuilder here, because our stream subscription here listens to another stream, and it can listen to a stream, that stream can possibly go on forever. If we're creating a multi-page app within Flutter and our stream never comes to an end or never comes to a natural conclusion, then it becomes possible that you can have all these stream subscriptions open and just listening to these streams forever. And that can become problematic from a memory management perspective, where you can slowly run out of memory. It can also create issues where you think that streams haven't been listened to and they have, and you reuse them, and all types of bad things happen. So normally what we do, just to be safe, and what's a very good practice to get into, and what you have to do when you're using your stream subscriptions, is within your dispose function for your widget, you have to cancel the stream subscription. And canceling that stream subscription cancels the subscription and prevents it from causing memory leaks or something like that. So just taking it back to the presentation briefly. So in a nutshell, that's how that works, the StreamBuilder and the StreamBuilder Flutter itself, and how we can do some light error handling and how all that goes together. One more thing we're talking about is that within the streams that we have within our applications, just like you can call map on a list or iterable, you can also call map on a stream. So as you would expect, if you called .map on a list or iterable, it's going to convert, it's going to undertake the operation you've specified, which is usually converting from one type to another. And it's going to do all of those things in that list or that iterable at once. In a stream, though, it's a little bit different. It'll yield those new types that you've specified into the calling stream or wherever it is that you would like it to be. Yeah, and very useful to transform a stream from one type to another. So that's how you can use streams within your Flutter app and how you can make them work for you. Thanks to Jack for setting up tonight, for coming along. And that's if you have any questions, now's the time.
Thanks, Lewis. That was a great presentation. I do have a question. I was wondering, are there any use cases where you wouldn't recommend using streams?
Broadly speaking, I mean, it really depends on the type of data you're interacting with. If you're, short answer, no. I guess if you're doing something that emits a result once and doesn't have any more results after that, then you probably should just use a feature over a stream. You shouldn't just use streams for the sake of using streams. There should always be a implementation requirement for it, which is normally just there's more than one event over time.
And are there use cases where people aren't using them where you perhaps think they should? For example, if they're abusing change notify.
Oh, yeah, there are times when things like that happen, and you do see things happen in the wild where they don't, like, well, for a long time, even myself personally, I was just calling .listen all my streams and using that instead of using the await4. There are times when you see them used incorrectly or not used at all because they seem like a hard concept to get their head around. But I mean, across the board, it's as time goes on, as a Flutter becomes a more mature language, and certainly we get good resources from Google as well, we do see that less and less.
Okay, great. Yeah, just like to thank Lewis once again for your presentation. It was really great. Very much looking forward to having you back for another time. And thanks,
Jack.
Yeah, and thank you to everyone who joined on the call today. And just a reminder once again that a recording of this will be sent out along with any information that Lewis would like sent out to all registrants. So we'll pop that in an email and have that sent out to everybody. And just once again, a reminder to anybody that we will have future meetups on our on the LogRocket blog. So be sure to check those out and look forward to seeing you next time. Thanks, Lewis.
Thanks, Jack.
Okay, bye.